Good morning. I'm Steve Thompson. Today I want to talk about SciKit-Surgery.F.R.E.D. SciKit-Surgery.F.R.E.D is a piece of software we've written for education and simulation with regards to fiducial market-based registration. So SciKit-Surgery comes from our software libraries. SciKit-Surgery, there's a link on the YouTube page you can follow. And F.R.E.D stands for Fiducial Registration Educational Demonstration. What we're looking at when we open the software is two images of a patient. We have an MRI image taken preoperatively on the left, and this is just a standard adult healthy male. And we've placed a little red marker here for the purpose of simulation. We're going to call this marker the target, and imagine that we want to carry out a surgical procedure where we want to hit this target and maybe ablate it with radio frequency or cold or something. Specifics aren't that important. But what is important is we can see the target on the preoperative image, but we can't see it in theatre. All we can see in theatre is the outside of the patient's head. And what we do in image-guided surgery is take salient information from the preoperative image and show it in surgery. So specifically, we want to take this target point and show where it is on the in-theatre image. We do that, or one way to do that is with fiducial markers. So we can place little markers on the outside of the patient's skull that are visible in MRI and also visible and locatable with a pointer or something in theatre. And once we have sufficient markers, we can do an ordered point-based registration and match the preoperative image to the intraoperative. So we'll place one marker, we'll stick one up here. F.R.E.D's quite permissive about where you can place markers. Obviously, in practice, you generally can only stick them to the outside of the patient's skull. This software will let you stick them anywhere. We'll try and stay physically plausible. We'll stick one up here. And if we have a close look at what we've just done, this is the important point. We've placed a green marker here, and we've actually put 2 points on the image. There's a black crosshair, and that black crosshair is the exact known position. Because it's a simulation, we know the exact position where this marker should be, and that corresponds exactly to the point on the preoperative image. But in practice, there's always an error in localizing these things, and that is known as the fiducial localization error. This particular example is running with a fiducial localization error with an expected value of 5.3 millimeters. It's a two-dimensional error, it's isotropic, it's normally distributed. As we place different markers, we'll get different errors. We'll go back to that, and we will place, when we do our little zoom operation, we place a marker. We'll place another one over here. Once we've done that, we can then see the target. We've got 3 markers. We can perform an ordered point-based registration. We can see the target in the intraoperative image. And if we look closely again, there's the red target point. There's also a little black crosshair. Again, because it's a simulation, we actually know exactly where the target should be. And that's this little black crosshair, and it corresponds exactly to the point here. But then when we do the point-based registration, we have a target registration error. And that's the difference between the center of the crosshair and the center of the red circle. And what we can do, we can calculate what's known as the target registration error, which up here is TRE 2.87. So we know in this case that the actual target is 3 millimeters away from the predicted position. And if you're doing image-guided surgery, this TRE is what you want to know. But in practice, in theatre, on a real patient, there's no way of actually knowing what the actual TRE is, because to know that, you'd have to know where the target is. If you knew where the target is, you wouldn't need the image guidance system. So we have to use statistics and previous knowledge to try and estimate what the TRE is likely to be. And that's what the whole sort of field of research on marker-based and more general registration is about, trying to to understand how these algorithms work so that we can not just predict what the TRE is, but come up with a good way to communicate it to the surgeon in theatre so they can make decisions on treatment margins and things like that. So F.R.E.D allows us to do that quickly. You can run it. You can run it as part of a tutorial with your students to try and get across some of the key concepts in marker-based registration. We get these statistics up here, number of fiducials. For a single run, the expected localization error doesn't change. So every marker we place at the moment will have the same standard deviation on its error. We have the actual TRE. If we place our markers well, that should come down as we have more and more markers. And we have the actual fiducial registration error, which is essentially the residual error when we register these fiducial points. And that should generally go up as we place more and more markers. Now, in this box over here, we have two statistics, which is the expected value of the fiducial registration error and the expected value of the target registration error. These come from a very important paper from 1998 by Fitzpatrick on predicting error in target-based registration. You can have a look at the paper to see the actual maths. But what they show is, crucially, what we just looked at, that the fiducial registration error, they're both related to the fiducial localization error. Higher FLE will lead to a higher value for both of these. But as you place more fiducials, you'll get a higher F.R.E., and that is independent of the geometry of how you place them. The target registration error is different. It depends not only on how many fiducials, but also on the geometry of them. So let's start another run with, it's randomly selected quite a low FLE. We'll start again with a slightly higher one maybe. See what happens here. So we've got a target here. What we'll do is we'll try and do a bad registration by placing fiducials badly. We'll put, so if you read the literature, and it's sort of intuitively obvious as well, if you want to work out where this point is, you want to place fiducials at a good distance, as big a distance from it, so you get nice leverage, but also so that point is somewhere near the centroid of the fiducials. So we'll do the opposite. We'll stick 3 points down here, tightly together, and we'll see we get quite a large error here. It's large in comparison to the fiducial localization error. We'll run again and see if we can get it. Here we are. It's a higher FLE. We'll do the same thing here. We'll stick our fiducials down here, and we should get something rather nasty. Yeah, there's a much bigger error. But as we rebalance the pattern of fiducials, you can see TRE is 72 and the FRE is 3.8. As we rebalance the pattern, put some up here, there we go, it comes right down. The FRE's actually gone up, but the TRE has come down. So F.R.E.D allows you to do this quite quickly and instinctively. You hand it over to your students and get them to play around with it. Play around with placing fiducials in different places and different quantities. So you're not going to, anything more than about 10 is sort of not clinically realistic. But you need at least 4 for something sensible. And you can rerun it, you can press R and start a new registration with a new randomly positioned target. As we're doing this, importantly, behind the scenes, F.R.E.D is writing a log file of comma-separated variables, which you can stick into data analysis, and then you can get people to look at the statistics, looking for correlations between the various statistics we've got here, so FLE and the expected values, and the TRE. Because what we want to do clinically is use the values we can calculate clinically, so we can calculate the actual FRE, and we can calculate both of these expected values. Working out the fiducial localization error is trickier because you need a lot of sort of system analysis to calculate what your likely error is. You can certainly calculate these three, and then you can have a look at, if you can do maybe 100 registrations, you can have a look at correlations between these values and the actual TRE and work out which of these is the best predictor for TRE, what sort of uncertainty there is, and under what conditions the prediction works, and under what conditions it falls down. So that's SciKit-Surgery.F.R.E.D. Hopefully you'll find it useful. Hopefully you found this presentation useful. Thank you for listening. And there's links on the page below to tell you where to download the software and further tutorials on it. Thank you very much.